Let's start today's, right? The only way this works is I teach you as many tips and tricks as I know. I'm going to try to brainwash you this week to where when you look at a problem, you're going to think and look at the problem just like I do. Okay? Keep this handy. Keep your identities right next to you all week long. And watch how these work. You'll see after me doing 2 examples the flow of this week, like what the point is. Okay, we are trying to prove that this equals this. There are 2 guidelines that we need to have. So write these at the top of your paper. Number 1 is start with the ugly side. And I know that ugly is a relative term because I've seen some ugly babies, but their parents still think that they're pretty. And it doesn't matter what you tell them. I'm probably going to have an ugly baby now. But it's okay because I'll think he's beautiful. She's beautiful. Think of more complicated side, more complex side. Whichever side has the most going on, that's where you're starting, right? So I'm looking at number 1, and I clearly know what the ugly side is. The left side. So let me switch to a pencil because today is kind of tricky. I'm going to draw a line down my paper so that I know I can only operate on the left side. I'm not going to touch the right side. I'm going to prove that this equals 1. Rule of thumb number 2 at the top of your paper is, when in doubt, you will either substitute or simplify. And literally, all week long, we're either going to be substituting or simplifying. If you can't substitute, you probably need to simplify. If you can't simplify, you probably need to substitute. Okay? And we've got to just get an eye for these identities. So here we go. I'm going to call on a lot of you, not to call anybody out, but just to try to keep us involved. Anthony. Number 1, on the left side only. Does anything jump out at you that screams identity on your page?
Yes.
Which one?
Secant squared x could be 1 over cosine squared.
Sure could. Let's do it. Let's follow it. Let's follow his lead and see where that takes us. Secant squared x could be cosine squared x. And remember, we learned Friday, it's always good to convert to sine and cosine. Okay? Anybody else? Do you guys see what this could become?
Cos squared.
How do we know that? It's one of the number 6 varieties. So this is cosine squared. So hey, what's about to happen here? These cancel, and we just proved that 1 equals 1, which is what we were trying to prove, and you can give yourself a check mark. Once you get each side to equal each other, you have proved it, and that's your job. You're done. The way I'm doing homework this week is I'm not going to go and look for checks. I'm going to go and look for, have you done the work on every single one of them? If you can't solve it, then just don't check it. Don't try. I'm going to fool him and check it anyways. Just be honest, because I'm grading more for did you try than a lot of checks. But I do want you to start getting the habit of doing this. When you finish it and it's right, check it off for yourself. 1, it just feels good to say you're right. But 2, it lets me know you did it right. Okay? So that was an easy one. Let's get a little harder over here. Heather, which one is the ugly side?
It will be 1 minus cosine squared x times secant squared.
There's a lot more going on over there. So let's draw a line down the equal sign, and we're going to stay on the left side. We're going to operate on the left. Okay? Josh,
Yeah.
does anything up here jump out at you and says identity on the left side?
1 minus cosine squared.
What is that saying to you?
It says sine squared.
Sure does. Sure does. And then, Jessica, how could you rewrite secant squared? 1 over cosine squared. Perfect. What's going to happen here? Yep. If you can't substitute, start simplifying. So let's just follow our rules. Sine squared times 1 is sine squared. 1 times cosine is cosine squared. And hey, what is sine squared over cosine squared? We're done with 2 of them. And check it off. because you proved it. Yes.
Could you work the other way, like if you change the squared x into the sine over cosine, and then you have sine over cosine equal sine over cosine, does that constitute as being done, or should you have it so it's tangent?
So this is important, what she just asked. She's saying, could we have maybe stopped here, converted tangent to sine over cosine, and then you would have this equals sine squared over cosine squared? That's proving, but that's not the way they want it, they being just math people in general. You want to only work on one side.
Okay.
So you could start on the tangent side, but you would have had to convert this to that, and that's a pain. It's always easier to go to the complicated and work small.
Okay.
But yeah, you can't mess with both sides. Like down here with this one, I had a guy in third period who wanted to just add 1 to both sides and then do some stuff, and we're not doing that. We're not solving, we're just proving. Okay, so you're on one side working your way around. Okay? Okay, I'm going to do 3 and 4, and then you guys are going to try a couple. Does something jump out at you? Back right corner. Anything jump out at you guys as just that says identity? Yeah, use your sheet. Huh? We're timid. We're right. Secant squared can be 1 over cosine squared. Because there's not really a big identity there, so let's just start changing some small ones. Right? Question.
Can't secant squared also be tangent squared plus 1?
Good question. Did you hear what he said? Secant squared could also be tangent squared plus 1.
But not for this case.
It could, but you have to start thinking, how would that help me? And if we changed it, it might cancel the 1s, and then it'd be what? Tangent, cotangent?
You can turn cotangent into a 1 over.
It might just be more work. I think you could actually maybe get it that way. His question was, I mean, this can be this, or it can be something else. You're just going to have to trial and error a little bit, Josh. Try something. If it's not working, try the other one. Okay? What could cotangent squared turn into, Casey? Look at your identities. What's cotangent?
1 over tan.
It can be 1 over tan, but since we just converted this to cosine, convert cotangent to sine and cosine. There's another identity that has cotangent as sine and cosine.
Oh, cosine over sine.
Yes. Minus 1 equals cotangent squared x. Okay. Actually, Josh, watch, because we're going to end up using the identity that you said. What happens? Cosines cancel, and we have 1 over sine squared x minus 1 equals blank. What does this turn into?
Cosecant.
Oh, sorry.
1 over sine can turn into cosecant. And then you just told me, well, it's not the same one, Josh, but it's close.
It's cotangent.
Which one of those identities has cosecant squared minus 1 equals what? What does it equal? It equals the cotangent squared?
Plus 1.
No, because it's minus 1, so it's already.
Yeah, this is one of those where you got to manipulate it, because look, it is this one. Wait, yeah, it is this one, but notice how, Nate, this one's cotangent plus 1. So what if it was cosecant minus 1? It would be cotangent, right?
Okay.
So if you see a cosecant minus 1, it equals cotangent, and then you just finish this one off. You prove that cotangent equals cotangent. Yeah.
Couldn't you have just done that from like the beginning? So you had secant 2x and then cotangent
Squared x.
minus 1, and then you could have just like.
Added 1 to the other side.
No, then you would have seen that it was like. Oh, never mind, sorry.
Sure. The reason why I was waiting is because there are a lot of different ways to do these. We just have to kind of mess with it. And now here's which one made me real mad. I actually remember learning this in pre-cal and being frustrated. Because here's what I want to do on this. Is this about number 3?
Yeah.
Okay, ask about number 3 before I go to number 4.
I don't understand how you, like the last step.
This to this?
Yeah.
So I believe there's an identity that says that cotangent plus 1 equals cosecant. Is that an identity?
Yes.
So then we can manipulate that to where, pretend that's not there and it's over here. This also equals that. We can go the other way. So we technically went the other way. Right? So here's what made me mad. Look at your identity sheet. Look at number 7. And tell me if it looks like number 4.
No.
Yes.
It looks the same to me. Tangent squared plus 1 equals secant squared. This is saying tangent squared. I mean, that is an identity. So I used to want to just say, I mean, that's true and check it off. But they won't allow that. The man's getting us down, right? You actually have to do this. You actually have to substitute. So we're going to use that identity. But if we're looking at that identity right here, secant squared equals this, right? So why don't I plug this, tangent squared plus 1, into this spot? So watch. Tangent squared plus 1. Then you got your minus 1. Now what's going to happen? Well, not distributive, because this isn't multiplying. This is just literally a plus 1 cancels with a minus 1, and you have tangent squared equals tangent squared, and you're done. So sometimes if you see a problem and you're like, that already works, you might have to just do one small step to make it work.
Why do you have the minus 1? Wouldn't that take place of the plus 1?
Yep, they canceled each other. Oh, no, because look, on the identity sheet, you've got to follow it perfect. Secant squared equals tangent squared plus 1. So when I go to this secant squared,
You're only doing secant squared.
I'm only doing this part, yes.
Oh.
That's why it's the tangent squared plus 1, and then that little guy stays out there, yes.
So like on a test, if I just wrote like,
If you just tried to check it off or something, it would not be right.
what if I like, wrote tangent squared x, like that side, 'cause I knew it was like the same, and then like checked it off, would you still mark it wrong? Would you want me to show all that?
I would want you to show it. Yeah. Okay, so we've done a few. Try number 5 on your own. And then we'll come back together. I'll do 6, then you can try 7 on your own. Try 5. And just remember our 2 rules. Look for identities that you can change immediately. If you can't, try to change everything to sine and cosine maybe. Okay?